All right, hi. What we're going to do here is go through the theorems and postulates for section 1 and for section 2. Now, in your notes, you should be making sure that all of this information is being recorded as I fill in this basic template. That means you need to make sure that you're including the section, the name of the postulate, the actual written out formal definition, and then any sketch that would apply to it. Now, it's important to note when we're dealing with the various postulates, if the name itself is not something novel, like the right angles theorem, or the vertical angle theorem, or the parallel postulate, then the name itself is not important to memorize. However, the implication of it absolutely is. So let's begin now with section 1.1 and the first postulate, which can be found in your book on page 7. Through any 2 points, there is exactly one line. So what we're saying is if I take 2 points, there are my 2 points, I can only draw one line that passes through those 2 points. If I were to draw a second line, it would have to curve, and that's not a line anymore. When I talk about postulate 1.1.2, through any 3 non-collinear points, there is exactly one plane containing them. So if I want to establish a plane or a flat surface, there it is, I would need 3 points that are not on a line together. If those points were to end up lined up, then my plane would tip and tilt around it. So the goal here is to make sure they're spread out to create that flat platform. Let's go down a little bit. Next up, if 2 points lie in a plane, then the line containing those points lies in the plane. So there's my plane. If I have 2 points, there's a line that contains them. That line's also going to be on the plane. If it wasn't, then they would have to turn or something. Postulate 1.1.4. If 2 lines intersect, then they intersect at exactly 1 point. So there's a line, there's a line, and they intersect at exactly 1 point. So the important takeaway here is that lines don't curve and keep crossing themselves. It's not like driving around in the lakes area where Commerce intersects Cooley, intersects Commerce, intersects Cooley. It's more like driving if you move out a little bit towards the east side, where there's exactly one intersection where Maple crosses Adams. Exactly one intersection where 16 Mile crosses Woodward. That doesn't loop back and do it 3 or 4 times. Postulate 1.1.5. If 2 planes intersect, then they intersect at exactly 1 line. Now this is probably the least intuitive of the section 1 postulates. This comes from the idea that if 2 planes are going to intersect, so here's a plane, and they're going to hit each other. They're going to hit each other at a line. So that point of intersection is linear. It's not a point. The area of contact forms a line. So no matter how I set these 2 cards together, I will always see a line where those 2 cards meet. So one card is a plane, the other card is a plane, and when they intersect each other, that intersection created is a line. You can see this if you look up where your ceiling meets one of your walls. You can see that line that's formed there. All right, that's it for the section 1 postulates. Now, the good news is that the actual names aren't that important. but a lot of the parts from what I filled in will be. So if I were to ask you, how many points do two lines intersect at? You know that two lines intersect at 1 point. If I were to say, describe the intersection of two planes, you could say that the two planes intersect at one line. That's what you need to know from this section, much more than you need to memorize things like postulate 115. All right, have a good one.